Welcome everyone to the beginning of our series on navigating the new era of low cost and inconsistent quality batteries. We have finally an abundant supply of batteries. They're incredibly low cost and high performance, really marvel of economies of scale. And today we're going to be talking about the first part of our four-part webinar series, kicking off with state of the market. So I'm going to be one of your panelists, Tal Scholklopper. I'm the CEO and co-founder of Voltaic. And joining me for the series is Dan Torelli, our senior battery engineer based over in the UK. So we're going to be talking about really how to ensure the reliability of these batteries as they're being integrated into EVs continually, and also in a range of new applications. Probably the largest other beneficiary of low-cost batteries is battery energy storage, and we've seen the challenges with some of these integrations. So this is the first part of the series. The coming session is going to be on May 2nd, and going to talk about how to qualify cells for systems and pack production. So starting off at that beginning of the journey, before you even choose your supplier, how do you actually make sure you're choosing the right supplier for your specific application and needs? Next up is how do you actually sign a good agreement with those customers? It's not just a commodity product that you buy. You have to make sure you have the right warranty. You have to make sure that you navigate that relationship effectively so you're getting good batteries from those companies as well. And then finalizing the journey, once you sign that contract, you're moving into production, you're putting batteries into customers' hands. How do you continue to ensure the quality of those batteries over time? And that's going to close off on July 11th. So hope to see you all there. And again, we'll be sending these out as recordings afterwards. So no need to take any notes. So you'll get this one right after, and we'll post on YouTube after as well. This is one of the fun charts I like to show recently from Goldman Sachs, just talking about the battery price forecasts and even continuing to see downward pressure on price points. And really, there may be some like ups and downs here as supply constraints get worked out of the system, but we've really entered this golden age of electrification. We're just reflecting on it. Today's the 13th birthday of Voltaic. Right before Voltaic, I was working on a Department of Energy RBE program, and the whole premise there is lithium-ion batteries are $1,000 per kilowatt hour. If we ever want to get anywhere in next generation technologies to get under $100 a kilowatt hour, and look where we're at now. We're with lithium-ion, we're substantially under $100 a kilowatt hour, and are going to continue to drive lower and lower going forward. And so economies of scale are real and make it a really exciting time for us now. The challenge for the market is a lot of this is powered by economies of scale in China. They really invested in building up the supply chains end to end, from mine to processing to domestic consumption to really power this. And especially now with tariffs, you can't ignore that right now. China is now the lowest cost supplier, but there's all of a sudden, if those tariffs increase to really levels that can't be sustained, it's really going to create challenges with navigating optionality and making you able to power your devices with batteries that are affordable. And so trying to figure out now, how does the world actually stay competitive as we're dealing not only with the China effect and their dramatic efficiency gains and economies of scale, but on the other side, the challenge around tariffs today. So overall, we are still seeing dramatic expansion in battery production capacity. Some of this has been shaved down already since the middle of last year, but we do continue to see an increase in electrification. We're going to see a little bit of some of these shifts where it's going to be more hybrids versus BEV in certain regions, and many batteries are going to go actually into stationary energy storage. And I actually predict we're going to see a larger percent share of stationary energy storage going forward. You look here, another chart from the International Energy Agency is looking at battery storage growth, especially on the grid. And that is now actually the largest growing area in electrification or clean tech as a whole. One of the fun charts we like here is Canary Media put this together. It is now actually cheaper to deploy renewables plus batteries than it is to deploy traditional combustion-based power plants. Even if you want to put in a nuclear power plant, it's going to take you 10 years. I think they're talking about with wind to get shipment of, you place an order now, it would take 5 years. Renewables, you can go get panels today. You can go install them, similar with batteries now. The multi-year lead times are gone. And we're just going to continue to see adoption of batteries and renewables on the grid to really balance some of these challenging loads. And then there's all these interesting opportunities now around things like data centers as well. There is a range of data centers now being built at a very rapid clip around AI. And to power those, there is not enough consistent baseload power to supply those data centers. And so, again, where do we go? Because we can't put in place new baseload very quickly. It's going to be batteries plus renewables. And so, just continue to see this trend. It's going to accelerate. And as more batteries get consumed, the prices are going to decrease. Is going to create this virtuous feedback loop as well. So the challenge here, even before tariffs, is China is meaningfully ahead at this stage in battery production. We started to see this initially in their domestic markets, where we started to see all of the foreign companies who had put in place facilities there, whether it was for batteries, battery production, or for EVs. They started to really struggle around those local markets and started to very rapidly lose market share. And then we started to see this very rapid export push with, if you go to a lot of Latin American markets, you go to the Middle East, you're seeing a lot of Chinese EVs. You're seeing batteries from China now competing on very large energy storage projects. And that's creating a large challenge for the rest of the world who is not at that same scale and has higher price points around a lot of these batteries. And then on top of that, now we have tariffs that are jumping in. And I think that's going to make it potentially cost prohibitive to get batteries from China. China may also flood certain markets, which may lead to more tariffs. If we end up with this tit for tat, it's really going to become challenging to figure out, hey, do we start really accelerating these domestic production in the rest of the world and really navigating this going to be very dynamic market right now? The challenge is outside of China, which has really built this robust infrastructure of spinning up these facilities. They still have challenges there. I can talk more about that later. Even the companies who've been making factories for decades are still struggling around new lithium ion production. So this is a large gigafactory that was started in North America around 2017. It actually took them 4 years to get to initial profitability from that factory, as was publicly reported. So that's a long lead time when you're putting in billions of dollars into a factory as you start then hiring thousands of staff. And then you think about all the consumables from energy to materials. Really, that's creating a big pressure point on companies for making very large investments to get these factories up. Similarly, this is a European factory with a Korean supplier that started production early 2018. Whole range of issues. A bunch of the European OEMs who were relying on this factory for EV launches had to delay those launches. And there's been a string of continuous issues there, both from product release and slow production yield ramp, but also in terms of warranty returns as well. And then, yeah, the Scandinavian Gigafactory, everyone can guess this is Northvolt, started production late 2021, only got to about 1/200th of the yield at the end of 2024, that should say, and then got into bankruptcy. And so this really creates a challenging picture. We can't take this long, especially if these tariffs are coming now, if the flood of these low cost batteries from China is coming. We can't go this slow if we're going to be competitive. On the other side, if we move too quickly or we don't do this correctly, we're going to deal with the repercussions, whether it's a warranty event and just a return, or in the worst case scenarios, actual safety events that we've seen in a whole range of industries. So this is a picture of Moss Landing, I think about a month and a half ago, starting to see some of these fires start to emerge. And this is, again, with tier one battery suppliers. That one was LG. Samsung just had a recall about a month ago as well, across 180,000 vehicles. And this affected a whole range of OEMs, FCA, Audi, Ford as well. And then fires even on ships and transport. And so quality is really going to become important. It's not just making sure you produce these things, you have to produce them and ensure their quality. Otherwise, you have a time bomb on the back end that's really going to create these pressures and profitability for companies, may potentially even drive bankruptcies. And let's talk through a little bit why this is so challenging. So let's talk about the challenge here with batteries. Starts with product development. So we have cell suppliers, we have OEMs. Mostly in the rest of the world, we still have, at least in the US and Europe, it's Asian suppliers primarily making the batteries on this side, and then we have the OEMs manufacturing the modules, packs, or at least doing the system integration into the vehicle or the grid or other systems. And challenge number one here is around identifying these problems. So as we saw on the last slide, some of those problems are popping up in the field. That is the last place you want them to happen, especially as a safety event. And so we want to start catching these problems as early on as possible. Next up is, even when a problem does occur, figuring out the scope and root cause of those issues. So let's look at the example of those Samsung batteries, and not to pick on Samsung, this is an industry-wide problem, but these safety incidents, all of a sudden one car has a fire. You do an investigation. Does that require a recall? Is that something that should be fleet wide, or is that isolated to how that driver drove that vehicle? Is it something from that assembly that happened from that specific day? And without that ability to actually look backwards and figure out where those problems are coming from, you end up with these fleet wide recalls, and that creates a lot of uncertainty, let alone figuring out how to fix and remediate those problems. Just figuring out what is affected as the second big problem here. And as we look across this life cycle from production, the cost of finding these defects increases exponentially as you move across this journey. So let's say we have a $10 battery cell that's coming from the cell supplier. Ideally, you catch issues even further upstream before the cathode is assembled fully into a battery. But let's say we ship that battery. The next stage, once it's shipped to the OEM, who's going to be integrating that into modules, packs, and systems, let's say it's just shipping costs. So if you can, with your incoming inspection, catch those issues, again, much, much cheaper. As we go further in this journey, you've assembled that battery into a module, pack, or system, or rack, cube. We have all kinds of fun names now in the battery industry. But yeah, it's now you have sometimes tens, hundreds, thousands of batteries now assembled into a system. It's not only the cost of the batteries, it's the entire balance of plant. It's the housing, it's the electrical, it's the thermal, everything else you put around that system. And that makes it a much more costly defect once it gets to that larger level. And then the last stage is, once that gets out into the field, it is not only the replacement, which is similar, it is also this very, very high cost of dealing with those returns. You have to do investigations with customers. You often have additional warranty liabilities tied with those. You have to send service people to go and deal with this stuff, let alone if you have a fire or safety incident, and legal and insurance implications as well. So this gets very expensive every step you go along the journey. So you've got to catch these things, quality issues, as soon as possible. So how does the rest of the world stay competitive here? For OEMs, we have to learn how to leverage low-cost cells. Right now, even with the tariffs, Chinese cells are still cheaper than many of the cells that are produced in the rest of the world, just with where they're at and some of the oversupply they have right now. For cell suppliers, we have to figure out how to achieve scale rapidly. And then for all of us, whether it's an OEM integrating batteries and trying to figure out if they're getting cells from China or other suppliers, or cell suppliers as you're shipping batteries, quality is at the end of the day going to be king. Even if you're shipping batteries and generating revenue, if you have those batteries returned, if you cause safety incidents, you're not going to survive long term. And so quality at the end of the day is king. It needs to drive all of this in parallel to scale. And then across the industry here, really looking at leveraging software and tools, whether it's statistical analysis, automation, AI, we're going to have to learn a whole lot faster. The only sustainable competitive advantage is how quickly you're able to learn from information. So that if something does go wrong, or as you're iterating, that you could really learn and get these things out the door and ensure quality. You're going to have to do more with less. Teams are going to be, the era of cheap money is gone. No longer will people be able to raise $15 billion on a dream. If the factory is taking longer, it can't just go raise another billion or two. And so you're going to have to do more with less, and you're going to have to figure out how to do it faster. So scale faster, ensure quality for across this industry. This webinar series in particular, we're mostly focusing on the OEMs and the consumers of those batteries that are putting them into products. With that, I'm going to actually pass it over to Dan here, and we're going to start talking through how to qualify your batteries.
Thanks, Tal. Yeah, I think you're absolutely right. The battery industry is in a really interesting place right now, as this oversupply of low cost Chinese cells is making it cheaper and cheaper to electrify a number of different industries. But as you correctly pointed out, there are a number of steps that OEMs need to take to ensure high quality battery packs are put onto the market. As you mentioned, this is going to be a 4-part webinar series on this topic, where we do a deep dive into different methods of ensuring battery quality. But I wanted to set the stage and introduce some of the key areas OEMs can concentrate on to improve battery quality. And it really starts right from the beginning as you're qualifying your cell supplier and pack design. So as you begin this process of design qualification, you're going to be choosing a cell supplier. You're likely going to be evaluating a number of different options across a range of different prices and designs. And developing a good relationship with those suppliers is key to ensuring a successful partnership. And we'll discuss this in more detail and some of the things you can do to set yourself up for success when you're negotiating with those cell suppliers. You also want to test your cells and make sure that they're up for the task of whatever application that you're targeting. And you want to ensure performance will meet expectations in real world use cases, but also, in my opinion, even more important than testing sort of typical use cases is testing worst case scenarios or worst case use cases to understand how batteries in extremes of your applications are going to perform. And then based on the results of that testing, you're going to set warranty limits, and you'll need to verify these on statistically significant sample sizes and make sure that your cells and packs are going to meet those warranty limits, even when they're operating at the upper and lower ends of your design limits. As you're going through and you're choosing your supplier, cell design, you're testing your cells for long-term performance, you really need to keep safety at the forefront of your mind. And by conducting sort of a range of abuse tests, including those required or specified by the various standards that apply to your application. But you also want to consider doing bespoke or tailored testing for your specific design application to ensure that cell level failures don't create hazardous situations for your users. It's also important to remember as you're performing these safety tests that most standards call for testing new cells or maybe moderately aged cells. The cell state of health can have a huge effect on cell or pack safety. And so testing batteries with varying states of health can help ensure safety conditions are going to be met throughout a pack's lifetime. During the design phase, you'll have a unique opportunity to develop your income inequality control protocols. So you're going to be aging cells, you're going to be cycling them, you're going to be measuring end of life performance. So this is a really good opportunity to put the cells through a range of potential IQC tests and then determine what are good predictors of end of life performance. And then lastly, it's important to understand how your cells age or degrade so that you can improve your pack performance. And so by conducting thorough post-mortem analysis, information on degradation mechanisms can be gained and design controls can be implemented to prevent or at least delay some of these failure modes. So as you begin the process of choosing your cell supplier, you're likely going to be evaluating a number of different suppliers, probably a bunch of different cell designs. And then based on your requirements, you'll design a number of different tests. You're going to generate a substantial amount of data, which needs to be carefully analyzed in order to understand sort of the benefits and drawbacks of each of these options. Probably going to evaluate some spider or radar charts to evaluate the performance of each supplier and design options. And you can optimize for the variables which are the highest priority for your application. And I think it was an interesting point you made about the tariffs and geopolitical forces. And I think this really comes into play when you're qualifying your suppliers and your designs. And you want to make sure that you're qualifying multiple suppliers, potentially from multiple different countries or potentially domestic and imported, so that you don't have any sort of disruptions to your business after a political election, let's say.
That's a good point. I think if you look across some of the larger companies in consumer electronics, they've really learned that lesson the hard way, whether it's a flood in a local region or whatever it is. When your companies are really dependent on batteries in your consumer electronics, if you're a consumer electronics company, you're going to qualify multiple suppliers. So in case one of them has an issue, you have a backup. We also see this in a lot of defense applications. And I think going forward, the rest of the economy is going to have to figure out how to do the same thing, whether it's these regional tariff disruptions and trade wars, or just the assumptions that certain battery plants are going to spin up fast enough. You need alternatives. And so that's really going to be key going forward.
Yeah, and the medical device industry does that as well, because if you make a change to a supplier in the medical device industry, you have to go through and show that it's an equivalent to your previous supplier. And so as you're going through that design qualification phase, you need to have multiple suppliers in case there's any sort of disruptions like that. Okay, so now you've selected your cell supplier, your cell or pack design. It's time to start negotiating. And so the focus of these negotiations is almost always going to be on price, but there's a lot more to consider than just price. So you'll need to decide on the specifications for your cell, but also the tolerances. And you have the ability to negotiate on these tolerances and decide what is and is not acceptable for your application. And so by using data from that design qualification testing, you can arm yourself with facts at the negotiating table to ensure that the cells you're receiving will meet your design needs. Similarly, you're going to need to decide on lifetime requirements when cells are used for your specific application and how replacements are going to be handled. And if replacements come up, who has jurisdiction over making those types of decisions? So these are all sort of things you need to consider. Also, the ability to audit. This is becoming more and more common, particularly for large scale agreements, but the details of those audits are really important as well. So you need to figure out who's going to have access to the facility, how often are you going to be able to audit, how are the findings from those audits going to be taken into consideration, I think is probably a very important issue. Just going in and auditing the process probably doesn't do you a lot of good if you can't actually action on some of those items that you find during the audit. And then lastly, and possibly most importantly, is getting access to the data on your cells, on the cells specifically that you're going to be purchasing. Suppliers might be reluctant to hand over all of the process data for the cells, but I think even small pieces of data can go a long way when you're trying to determine sort of the quality of the cells that you're getting. So things like simple voltage measurements, resistance measurements, or ideally even raw time series formation data can be provided. We've seen plenty of examples of these sorts of data sources being provided to OEMs so that they can evaluate the quality of incoming batches of cells.
And as a reminder, we're just giving, I think, little snippets here at a high level of each of these areas. And in the coming webinars, we'll actually have full deep dives on qualification, supply, and then actually going into production as well. And looks like we may actually work in maybe even a fifth webinar on end of life as well. So we'll keep you posted there.
I like it. Let's do it. Okay, so we talked a lot about data and all these various tests and processes, which are going to produce a huge amount of data as you move through sort of the design stage to prototypes or pilot scale, and then up through full scale production. But it's really important to have a good way to manage all of that data so that you can make sure that you're extracting all of the value from that data. Data costs money, and it's important to get as much value out of that data as possible. And Voltaic is an enterprise software platform that has helped customers with exactly this issue for over a decade, 13 years now, as of today, and has developed the tools needed to integrate all of these different sources of data and to help catch quality issues before those batteries ship. This minimizes costly remanufacturing, manufacturing downtime, warranty returns, and recalls. So as Tal mentioned, or as we mentioned here, as you move from design qualification to full-scale production, you're going to be collecting data from a number of different sources, including from your cell supplier or the cell manufacturing process, through pack assembly to end-of-line testing, and even in-field use, depending on your application. And Voltaic plugs in to each one of these data streams and allows you to link this process data to the cell's electrochemical data, which we liken to the heartbeat of the cell. And so this heartbeat, when combined with process data, can not only identify defective cells, but with all of this process data, you can help trace back quality issues to the source. And this sort of rapid root cause analysis can identify battery defects quicker and, as Tal mentioned, save you literally millions, if not billions of dollars by preventing low quality cells from making it out into the field.
And a lot of these are just simple things. Very often, I just remember the first time we worked with a utility and they were having issues with racks and modules failing within their system. They gave us the data and thought it was going to be a long assessment. Literally looked at the first day of data and voltage imbalances across the modules within the racks. Like, a lot of this, it doesn't get a little bit of data, make sure you have the systems to look at them and the team that knows how to, and it's going to save you a lot of money. There's more that we can do as well that's more complex, but there's definitely some low-hanging fruit here that's going to pay big dividends if companies really invest in this.
Yeah, absolutely. So Voltaic has built-in battery workflows and experts that are in the trenches with our customers, helping solve these sort of complex, difficult quality-related issues. And we found that kind of no matter how similar each customer's application is to one another, no one company does battery testing or analysis the same as another. And so therefore, very important for us to make the platform completely customizable for your specific application. And we have software developing developers working with battery engineers like myself to ensure that your specific metrics or KPIs can be calculated with a click of a button in Voltaic.
Yeah. And that's, I think, one of the things we've seen that was really interesting. It's not only the testing being different and applications being different, but it's also the chemistries and you name it. But I was at a customer this week and there's literally, I think it was like 8 different flavors of engineering groups within the company that consume the data. There's other stakeholders who want it. And so that ability to not only configure the KPIs around things like the chemistry are useful, but on the other end, having more of graphical interfaces that people can customize and configure really is that other key. So having that for the non-native data native folks, but the fact that all that data is cleaned and featureized, whether you're using the application that's built for battery engineers, or we've seen this really dramatic increase in API and code first users within the software as well, within our internal coding environments, and also just API connections into other environments or tools that people are using the data in as well.
Yeah, I think the big one for me on that one is internal resistance of a cell. I've worked with tens of different companies, and I'm not sure I've seen anyone define that the same as another. So you can customize all of that within the application. Yeah, and one of the things that we really focus on is getting customers onboarded quickly so that you can minimize sort of lengthy delays. And we really aim to show value by the end of your first month with Voltaic. And then lastly, we work with gigafactories around the world. We have a proven track record of success at the enterprise level, and we're always happy to work with new customers in these areas. And I think that sort of wraps up our sneak peek here of the upcoming webinars. I just want to quickly plug the upcoming ones again. So today we discussed the state of the market and gave you a little preview of what's going to be coming up in these future webinar series. So on May 2nd, we'll do a deeper dive into qualifying cell designs. On June 13th, we'll discuss some of the nuances around negotiating those supplier agreements, as I mentioned earlier. And then on July 11th, we're going to discuss steps that OEMs can take to ensure quality during full scale production. And so with that, yeah, I want to thank everyone for your time and attendance today. And we got some time for questions. I think we've had a few kind of trickle in. Tal, I don't know if you want to maybe
Yeah,
take
let's
the.
kick it off. I've been monitoring on the side here as well, and it looks like we may do a 5th webinar as well on end of life and how to deal with that also. So yeah, the first one I was looking at here is on looking at new chemistries. We see new chemistries, sodium ion, solid state, there's lithium sulfur, there's a whole range of potassium batteries and others. Do we view them as legitimate contenders in the battery space, or is R&D going to take so long that lithium ion will own the market? Dan, do you want to go first?
Yeah, I get this question a lot and hesitate to go too far out on a limb on any of these.
I may,
But
yeah, jump because I actually, it was interesting. Right before this, I actually posted on LinkedIn. Dr. Hale Cheeseman from RPE, one of the directors there, had this interesting article on beating LFP is like trying to beat a toaster at toasting, just given the economies of scale. And I think a lot of his points were valid. He brought up actually some interesting, exciting technologies. I think the reality today is just given where the production volumes and price points are for LFP and other lithium ion technologies, it is going to be challenging to compete. And I do think there is a future for next generation chemistries, but it is foolish to think that you could really take that step and directly compete against them and scale rapidly and get those price points right away. It's just not going to happen. There's just so many of these. Forget even if you have that all figured out and the fundamental chemistry, how do you actually scale it? How do you put it into a system? How do you make sure it actually lasts for a 10-year period or 20 years? All of those questions take time to work out, and you need to do those incrementally. And so I think these chemistries will be valuable in the future. We'll see some of them commercialized at a larger scale, but it's really important to do that at the right pace and right stages. And so it's really doing that, choosing the right niches where you could actually have a differentiated value. That is like the first piece here. So if you're just going directly head on with LFP right now, unless you have a major differentiation that, more importantly, the market cares about, you're not going to be able to really compete long term there. And so Look for those applications that aren't viable, the flying transportation space. Look at things like data center with like very fast loads or temperature areas. Find that differentiated value and then figure out how to grow appropriately with those niche applications. And as you start growing, you'll naturally start building up those supply chains that will come to match you, and you'll be able to start getting those benefits of economies of scale as well. But don't go directly at the king. You won't make it, but figure out the right way to scale your technology and the right applications that actually are willing to pay for those differentiated battery cells.
Yeah, 100% agree. It's all about the application. And if you're trying to install new batteries in an electric vehicle, it's going to be difficult to come in with a new chemistry, especially some of those ones that you mentioned. But yeah, absolutely. If you're looking at stationary energy storage or aviation or things like that, I think there's definitely some appetite and room for exploring some of those novel chemistries.
Yeah, then another one we had here is actually texted. So a supplier won't share, and we hear this actually pretty often. My supplier won't share the data with us. How do we ensure we're getting high quality cells if they aren't sharing the data?
Yeah, I think that's an important one and something that the amount of data that different OEMs get can vary pretty wildly. And I think the important thing to remember is a little bit of data can go a really long way. Simple voltage measurements, I think, are a really good example. If you can just get an OCV measurement from the cells before they leave your cell supplier, you can leverage that time that the cell is in transit. Right. The issue with delta V measurements is they take a really long time to perform. You need time to pass. Your time is money. But if you can leverage the time while that cell is in transit from the cell supplier to your factory, you take a voltage measurement as part of your IQC protocol. Now you can do a delta V from the cell leaving your cell supplier to the time it goes into your factory. And that can tell you a lot about the quality of the cell. And we'll dig into this a little bit more as well in the IQC webinar, design qualification. But yeah, I would say a little bit goes a long way. And that's why IQC is so important, because not everyone is going to give you all of the data that you need to determine if a cell is higher or lower quality.
Yeah, and for those who are familiar, IQC is incoming quality control. And so that's really where, it's something we've actually seen lacking at some OEMs as they've rushed into the market. You really have to test and plan and figure out how to actually qualify your batteries as you're getting them from supplier. They're not just commodities. It's not just a piece of steel. And even with those, we've seen quality issues and issues there if you go back into the past. And it's important to figure out what you're looking for, how to make sure something's within the tolerances you're accepting through a supplier. And then two other things I think I'd note. One is I think the days of cell suppliers not providing data, it's over. That was, I think, due to this environment that we had where there weren't enough high quality, low cost lithium ion batteries, and took what you got. If you're signing with LG as a partner to guarantee supply for your EVs, you're taking what they give you. There was very little push and pull. There was companies pretended there was some, but really that was very limited. We're in a very different place right now with oversupply, both out of China, but also with the flood of it's a whole bunch of cell factories that were built in the US, and that provides the consumers of those batteries with more leverage now to really get what they need from their suppliers to ensure quality, and really dive into that in the third webinar here. And then I think the other piece here is just an anecdote going back a few years, and we see this over and over again. Even once you qualify a battery, if you get some data from your cell supplier, you have to keep checking. And all of these subtle little changes that happen, supplier switched a separator manufacturer, and they're like, oh, yeah, the specs are the same. It's fine. We swapped that out. And I just remember one of our consumer electronics customers, they had a battery cell, everything qualified. They put the product out there, and about 6 months into their sales, they started to realize we started to have a whole bunch of warranty returns from new manufactured products. And then when they started qualifying the batteries, they realized, oh, something's wrong with all of these. They got to actually work with the supplier, remediate that, and figure out. And so we see a lot of the more mature companies who've worked with lithium ion batteries for years now. They actually do periodic, whether it's quarterly or annually, they continue to actually requalify the suppliers, maybe not as large of a scale, but continue to look at the revisions. And as part of your supply agreements, actually contract out in detail what revisions are okay within a major product cell line that you're getting. You actually have to ensure that you're getting the right batteries for your supplier. And if they make a change, what is major enough that they need to notify you that you need to check that? Okay, so let's dive in here. Seeing a lot of questions about cost differentiation, and I think that is very dynamic, and probably others will speak a little better to that one. Interesting one. Dan, wondering if you have any thoughts. Current pricing, if you look at there's a very large, I think, spread between battery costs in different applications. So the question here is about home energy storage projects from Tesla being at a very different pricing for kilowatt hour. Even if you look at their mega packs or these large utility projects, or even what they pay for batteries in their EVs and packs. Interested in your thoughts there.
Yeah, I to be honest with you, I'm not too familiar with the Tesla Powerwall pricing
Mhm.
structure. So I don't know if I could comment too much on how they're pricing that out, but I think it probably gets back to the economy of scales and trying to understand where those cells are coming from, how they're making them, what chemistry they're choosing, and they're taking that into consideration, but also just trying to have Powerwalls hit the market and take as much of that share of residential energy storage as possible. I'm sure they're trying to price that competitively and price out some of their
Yeah.
competitors. So I suspect that's where they're coming from. But
Yeah, they
yeah,
actually end up being a bit more substantially more expensive than we get. They even price the warranties on their batteries within their vehicles. So it's interesting. I think it's just driven by, as Dan was talking about, market dynamics. Do you want to win the market? Do you have enough competition? Tesla, I think, because of their workforce, is prioritizing things that they could do at very large scale, which right now is these mega pack projects, which are very large utility scale batteries. And then it's really based on market demands and how companies are trying to competitively navigate those and just some of the margins they're looking for. Another one here, we've noticed, and it comes on with some of the other questions here. Seen a number of companies that have batteries that are completely within spec and they still have premature failure. We have this other question: is it true that failure is a when, not an if question? And yeah, just really that things can be in spec. All of a sudden, we still have failures, whether it's early, premature, infant failure, or if on the other side or later warranty. I'm just interested on your thoughts there, Dan.
yeah, failure being a when, not an if, is, I guess, a little bit of a matter of semantics about how you define a failure. If a failure is a cell degrading past 80% state of health or 80% its original capacity, 100% agree. It's a when, not an if question. If that's when is my cell going to catch fire and go into thermal runaway, hopefully that is an if question. But yeah, the question of specs, and everything's in spec. My supplier tests everything, it's all in spec, but I'm still getting premature failures. What's the deal here? I think it's really important to understand how those specifications are set. And I think making data driven design decisions when you're setting those specifications is really important. And so you're going through this design qualification stage, you're testing a bunch of different cells and suppliers, and you're putting them through a gambit of tests. And you really need to test statistically significant sample sizes. You really need to understand how those cells are aging, how they're failing, and you need to develop good predictors of those aging mechanisms. And so it really comes down to collecting the data, analyzing the data, understanding the data so that you can make informed decisions when you're setting those specs, because it's quite possible that you just haven't dialed them in as well as you think you have.
Yeah, and I think that's a key point. And I always go back to a quote from one of our advisory board members, Selena Mikolajczyk, who's been working across a whole range of companies from Tesla to Panasonic to QuantumScape and now Lighten, leading the battery efforts there. Battery manufacturing, she always says, is an unstable equilibrium. There's always something trying to push you across the edge there. And very often it's things that you're not measuring and you're not looking at. And there's this continuous balance of keeping the cost down and not over measuring, not putting in too much equipment. But then when these new failure mechanisms and things that you weren't measuring are out of spec, you could definitely do as much as you can up front to figure out what those specs should be, what you should be measuring. But there's always going to be new things that emerge, and all of a sudden you may need an extra measurement in the incoming inspection for the materials. You may have to look at the hardness of a particle, and previously you were just looking at particle sizes and things like that. It's going to be an evolution here, but the ability to quickly identify that you have a problem and start narrowing down where it's coming from is step one. Or step zero actually would be really testing and trying to understand what those specs should be in the first place. But even then, you may need to add more down the road as well. And continuous evolution here, and the key is just learning quickly so that you can figure out that those early failures are not going to continue and you're not going to keep making more of those. There's another question here around, we work across many customers across the space, and there's a question around metadata, naming conventions to enable consistent tagging of data in order to build the knowledge bases, verifiable, validated data. And yeah, this is just like a really interesting one. And I'll let Dan talk about it a little bit more, but it's really the folks like Dan who, one of the key things we found that our customers love about Voltaic is because we've seen this across so many different companies and across different end user groups and different life cycle stages, we've been really able to take that and build not only a framework within the software to allow us to tag, name, to store all the relevant metadata, the materials, the processes, the measurements within the software, and have that configurability as we talked about before based on clients' needs. But it's also this consultancy model of where folks like Dan come in. We come in and assess where you're at on your journey of having that infrastructure around analytics to enable your business. And we basically go through this maturity model. Let's make sure your data is properly labeled. Let's use what you have today. Here, how do we make this more robust going forward? You can't have every engineer doing things their own way. And we start to work with organizations. We come in, we assess where you're at, and really start guiding you along that journey and putting that all together.
Yeah,
And I'll let you.
we talked about like variations and different data analysis that our customers do. I would say there's even more, probably an order of magnitude more variability in the types of metadata that they're collecting, how they label that, how they track that. And this is, yeah, like you said, where the customizability becomes really important. I think we have probably a few hundred pre-populated or pre-configured fields that almost all of our customers are using. But yeah, it's got to be adaptable. It's got to be configurable. And this kind of ties into another question we got about new components or new systems that are being installed into cells and modules to help improve safety requirements, and how do we tie into those. And I think that's a really important point, that this is a continually evolving field, new technologies constantly coming on the market, and we have to be adaptable. You have to move quick, and you have to be able to integrate with new data sources, and certainly something that we think about on a regular basis. In terms of specific technology, there's definitely gas sensors that are being installed in EV packs that are measuring for gaseous byproducts from thermal runaway or cell venting, swelling, things like that. But also, just one of the things that I've seen a lot is the instrumenting of packs and how that's changed over time. If you look at some of the early EV packs, you're getting pretty poor resolution voltage data. Maybe you're getting the highest cell voltage in a pack or a module or a block of cells and the lowest cell voltage, maybe the average. Maybe you're collecting that data at some sort of infrequent intervals as the pack ages or as it goes through its life. But now with some of these recent improvements, we've started to see customers that are measuring every single cell voltage across the entire pack, sending that back to the cloud, tracking that, and using that as early indicators of issues. And you'd be surprised at how much information you can get just from a cell voltage, especially if you're getting every cell voltage in your pack at regular intervals. And that's also something that we can tie into.
Awesome. And then we have another question here about across our customer base, we get to see a whole lot of this. Do we have any blacklists for customers? And I just want to address up front, we never share any customer data. We never share anything sensitive, any IP or custom code or anything customers are developing. We provide a framework for customers, our software platform. It is your system, it is your data. You manage permissions, who sees access, and we'll be as consultative as you want us to be, or just drop it off, integrate it, and let you go. But yeah, I think the thing that we do is really bring best practices around what to check when you're working with suppliers, and really start to help guide customers to what to measure, what to collect, what to bring in, and then we let customers make their own decisions. And the reality of where this industry is right now in its rapid growth, its new chemistries, new form factors continuously, there's not consistency. Some suppliers may be good on existing product lines. All of a sudden they release something new and there's all kinds of problems. And it's really about that, knowing what are the right checks to get confidence in those suppliers that you have to build up at each of those stages. Yeah, I think it's a continuous journey here. The fun question, I think it's actually comes to play with the tariff announcements this week and some of the coming trade wars. Considering the advantages China has over the US, labor, politics, I'm going to add supply chain over there. Should the US and the rest of the world give up on EV batteries and focus on other things? It's an uphill battle. So just interested for your early thoughts there, Dan.
Yeah, it's an uphill battle. It's that China is no question ahead of all the other markets here in this area. As we discussed, these things change quickly. Geopolitical forces can cause quick changes. And yeah, I don't necessarily think it's time to throw in the towel by any means. I think it's also important, though, to keep in mind the market that you're selling these things in. I'm based in the UK. Can't tell from my accent, but I'm based in the UK and work regularly with the Europeans. And the drive for electrification is huge out here. The drive for domestic cell production is huge. And yeah, I think that's not going away. There's constantly going to be a push for green technologies, electrification, domestic production, and we're going to need to find ways to compete with China. But I don't think the appetite for that is going anywhere.
Yeah, I agree. And especially with these coming trade wars, I think there's going to be a strong push to diversify supply chains. A lot of the things that used to take a long time, whether it's permitting and regulatory issues around starting to mine and doing precursor production in different regions, I think based on national security and uncertainty around these things, I think we're going to see some of those barriers decrease. I think some of this also creates a unique window of opportunity for certain companies and certain geographies to really, if you have these tariff protections that it's unclear how long they'll last, if even if they do come in, it could be a week, just given the craziness that we have these days, or it could be 3 years if there's another administration that comes in. All of a sudden that could disappear. And you have this sort of unique opportunity where it does seem like, at least right now, that if you make those investments, you will be protected to some degree. And that gives you this opportunity now to make those investments, get those products out the door, make money from them while you have those tariff protections. But then, yeah, you have to be long term. It's about achieving scale and being competitive because there's no telling how long those protections are going to exist. So definitely going to be a dynamic environment here. And I think there's going to be a continued push here for localization around the world for production.
Yep,
Excellent.
agreed.
Yeah, I think we covered most of the questions here. Happy to continue the dialogue from here live. Definitely reach out, whether it's through email or other mediums. Happy to continue the discussion. And again, we have the 3 upcoming webinars. And then, yeah, as a reminder, we'll be sending these slides out. Definitely reach out. And if anyone wants to dive deeper, whether it's into the product or just to talk about batteries in the market, let us know. Really grateful for having everyone join us today and looking forward to seeing you on the upcoming events or in person somewhere. Great to see everyone.
Yeah, thanks for joining, guys. We'll talk soon.